yes, I actually can do number one. So number one's given by I changed this to 4x to the negative 1 before I found the derivative. Don't start. My biggest problem with easy problems like this is I start getting derivative and antiderivative mixed up in my head. So it's hard for me to remember which one. I always start getting mixed up. All right, so we're going to multiply around, and then we're going to subtract 1. There's your derivative. And it says to do the antiderivative, right? I mean, no, derivative at, geez Louise, Stacy, this is derivative. You're laughing at me. Stop. Thank you, Brian. Negative 1 plus 5, which is 4. So 8. How about number 2? Good. So, and here's probably where you're getting antiderivative and derivative mixed up again, like I did. 6e to the 3x. I pulled the 6 out front. E to the 3x. I made u be 3x. I made du be 3, which means I need to counter out here with a 1/3. So I end up with 2 e to the u du, which is 2. E to the u is 3x plus 2. Okay. How about 3? We all know that the limit does not exist at 1. Four actually. You just said that. You said I need 4 actually. But then I didn't. You say, why do I keep saying it or why do you keep saying it? Oh, I don't know. I keep saying it because you keep saying it. All right. Deal. If the derivative is I'm on the struggle bus today. 3x squared plus 2x, and this was a fundamental theorem problem. I don't know why fundamental theorem on this test and last test have started showing up so very much. Okay, so fundamental theorem, remember, is simply how we evaluate an absolute. I think that's what I did. It's probably who I was supposed to be here. What did I do? What did I do? Oh, I did antiderivative and solve for c. So antiderivative of this would be x cubed plus x squared plus c, and you know f of 2 equals 3, so. And you found that c equals -9. And I'm running kind of fast through it so we don't get bogged down in time. But that means that that f of x is x cubed plus x squared minus 9, and then you just plug the 1 in, and you get b -7. Okay. We're just taking a 3-day off. I like coming for y'all, but past first block, I'm ready to go home. Maybe she does. You know what? I was wrong. She's not okay. I need to go. Right. There you go. How about what are you fussing at Joyce about? What about number 5? During an evacuation drill, bleh. Did we get that? 1150? That was right, Raymond's son. That was a pretty straightforward. Going once, going twice. All right, how about number 6? That derivative, that was chain rule, or that was product rule. Y'all good? 7, particle motion. I thought 7 was a little involved. Y'all need 7? The particle moves along the x-axis so that any time when t is greater than 0, its acceleration is... Yeah, I got bogged down on this one. Yeah. I appreciate your effort of eliminating or trying to eliminate. I took a lot of time on this. I'm trying to see what exactly I did here because I've got a lot of work. I think I might have done too much, but let's see. It asks you, it gives you initial velocity, and it gives you initial position. Okay, so I did too. I did that. So the first thing I did, because this is what you're looking for. You're looking for this equation, right? So the very first thing I did was I integrated and found antiderivative. But whenever I did that, I had to do a simple little u sub. Okay, so this would be velocity, right? Because that's going to be the antiderivative of acceleration. I let u be 2t, du be 2. So that means I need a 1/2 on the outside. Y'all with me? Is that what y'all did? Tell me if you didn't. So -2, the antiderivative of sine would be negative cosine. I had to counter that because I needed du to be 2 dt. So velocity is 2 cosine 2t plus c, but I need to solve for c, and I know initial velocity is 7. So 7 equals 2 cosine 0 plus c. What's the cosine of 0? So 5 is c. So my velocity equation, which is still not, that's why I said this was very involved for a multiple choice question. Cosine 2t plus 5. Now I got to do it all again. Because they asked for position. They asked for an equation for position. So now for position, I'm going to... Well, at this point, I would say it's A because if, as I look at it, I see this 5 on the end. So I know I've got a 5t on there, and there's only one with a 5t, which is A. So you don't need me to finish? All right, how about 8? So for me, 8 was hard to go because it gives you this graph of the derivative, right? It's hard for me to go from second derivative to function. So instead, the way I went through this, because I started out going, okay, I did this whole thing. My second derivative is positive, then negative, then positive. So I'm concave up, concave down, concave up. That is what I did. There's only one that does that, and that's B. Are y'all with me? Because this does something like this. So this is the second derivative. So remember, everywhere the second derivative is positive, I'm concave up on the original function. And everywhere the second derivative is negative, I'm concave down on the original function. So that's B. So we're going to have a couple extra days at the end. So what I'm hearing is y'all need some practice on connecting graphs of derivatives, second derivatives. All right. How about 9? Did y'all recognize 9 being the difference quotient? That formal definition? Where if you plug 2e into this equation, is that what you're saying? Or you plug 0 in for x. Well, this one's got x's and h's. If you ever see x's and h's, you're talking about different quotient. Yeah. Like if it's like maybe the limit as x approaches 1 of some polynomial or something like that. You just plug in 1. With the difference quotient. Well, we do the derivative and then we plug it in. So, like here, we identify the function as being log of x. Does everybody see that? Because it's f of x plus h minus f of x over h. So, and what this does is this finds the derivative for us, right? So really what I'm looking for is the derivative of this, which is 1 over x. And then they say evaluate it when x is 2e. So I'm doing 1 over 2e. Which is a. That's the derivative of log x. When you see the x's and the h's, this on the end is going to be your function, and then you're finding the derivative of that. Well, remember we talked about derivative is instantaneous rate of change. No, but they said evaluate it when x is 2e. So then we plugged in the 2e for x. Robert, you good? How about 10? That was just redundant. That was third derivative. Do derivative, do derivative, do derivative. How about 11? What did I do? You have to do what you think. I did, let's see. The integral from -1 to 1 of f of x. Yeah, I split it up into the separate integrals. So, because, so what you have is you have this piece of a parabola and then you have this piece of a line. Well, this is easy to find the area under. The area under of this was a half if you dropped it. So, no, it's a triangle because it's a line. I remember sitting and staring at this for just a second and going, wait, I don't have my calculator, how am I finding? But then I realized this is a triangle, right? Or you could, but I have to divide up these integrals is the point that I'm getting to. So from -1 to 0, the area under x squared plus, and then I go from -1 to 1, and I'm using that other equation, which is x dx. So you could have done it this way, or you could have known that this was a half. I just knew that that was a half and went from there. Antiderivative here would be a third x cubed, and I'm evaluating from -1 to 0. I had a half here, or you could do a half x squared and evaluate from, this should be 0 to 1, sorry, from 0 to 1. Either way, you'll come out to 0 0 minus, then you get negative 1/3 when you plug in the 1, plus a half. Common denominators, you get 5/6. Which is You could have eliminated C and D from the get-go if you were running short on time. You know it's not negative because they're both above the x-axis. And you know it does exist because you can find the area under no problem. How about 12? We get past a certain point and then we need them all. 3x minus 10y equals 4 dy dx in terms of y. So I'm going to go through and find the derivative first. So 3 minus the square root of a tangent. Secant squared, that's one you really want to remember. I need to follow it with the dy dx because I am taking the derivative of y, and then that equals 0. So what I'm going to do is I'm just going to go through and solve this for dy dx. So I'm going to subtract 3, and actually whenever I subtract 3, I'm dividing by negative 1 also. So I'm going to say, to make this a little bit easier to see, remember secant squared is 1 over cosine, right? So 1 over cosine squared, instead of dividing by secant squared, I'm going to multiply by cosine squared to cancel it out, just so you see what's going on here. So I got 3 cosine squared y, which is b. I just took the derivative, but anytime you're doing, this is that implicit differentiation, where if I take the derivative of y, I have to follow it with a dy dx every time. And then I solve for dy dx. Good. All right, how about 13? Y'all get 13, or you just don't want to say yeah again? Yes, for time t is greater than 1, the position of a particle moving along that x-axis is given by p of t equals square root of t minus 2. At what time between 1 and 16 is the instantaneous equal to the average velocity? So the first thing I needed to do was find a rock. So I said p of 1, if you plug that in, you get 1. P of 16 would be 4 minus 2, which is 2. Yes? A rock would be 2 minus 1 over 16 minus 1, which is 1/5, right? This should be negative 1, right? And then I found a rock. So derivative of t would be 1/2 to the negative 1/2. And I find that at time, when does it equal? When does 1/5 equal 1/2? I'm going to multiply this by 2. Raise both sides to the negative 2, so it's going to flip over and square, so I get 25 over 4. Okay, f is a differentiable function and y equals time f of x squared like this. What is dy dx when... All right, so I found the derivative first. So dy dx. Derivative of sine, remember if I've got a trig, I'm doing trig and then moving inside first. So what's the derivative of sine? Cosine. And I'm replacing, I said when x equals 3, so I'm just going to put 3. So cosine of f of 9 is really what that's going to be. Now I take the derivative of this, so f times times, and here's probably where you missed this. I need to do it with x, so you do not skip steps. If I'm doing it this way, then I do cosine f of x squared, derivative of f, but then I have to chain that x with a 2. And so I ended up, what does that do? What'd y'all do, leave the 6 off? 15. The graph of g prime, the first derivative of the function g consists of a semicircle of radius 2 and 2 line segments as shown in the figure above. If g of 1, if g of 0 is 1, what is g of 3? Okay, so if you look, this graph, this is 4. This said the graph of the derivative of the function. Blah, blah, blah. Okay, so what I'm wanting, they're asking me g of 3. This is the one where I have to use the fundamental theorem. And they give me g of 0. So how am I going to relate g of 0 and g of 3 given the derivative? Well, if I do the integral from 0 to 3 of the derivative, because that's what I've been given, right? What that should give me, this would be area under, right? Area under this, because this is g prime. The way I find that, if I think about fundamental theorem, is g of 3 minus g of 0. Do you agree with that? If I were, so this is kind of a graphical approach as compared to an algebraic approach, but setting them equal to let me solve for what I need to know. So could I find the area under from 0 to 3? Sure. This is a half of a semicircle, so a half of a half with a radius of 2. So a fourth of a circle with a radius of 2 would just give me pi, right? The triangle with me. And this is a triangle, 1 and 2, 1/2 times 1, which is 1. So this integral should equal, now remember they didn't ask me for this integral, they asked me for g of 3. So that integral should equal pi plus 1. So pi plus 1 should be g of 3 minus g of 0, and they gave me g of 0. G of 0 is 1. And so now it's easy to see what g of 3 is. Adding 1 to both sides of the graph. Yeah, it was giving me the derivative, and it's asking me for g. So I knew I had to go backwards with it. We did the area under the curve because we didn't have an actual equation. So we couldn't find the antiderivative. So instead, we did area under the curve geometric. And set that equal to if we had done it algebraically. Because of what they asked me. That's the key, is looking at what they gave you and what they're asking you for. I have an asterisk by 16. Did y'all struggle with 16? I got it wrong. But what did I do? I'm not going to go back and work it. I just circled it. F of x is x cubed. I put b for this one. That's wrong. Maximum value from 0 to 6. Now remember, maximum value means your y. Okay, if you ever see value, that's y. If you ask where it happens, that's x, but value is y. I did oh, I see what I did. I went outside the interval first. Okay, so derivative here, 12x minus 15. Yes? I want to know where that equals 0. I can take a 3 out. First off, it factors nicely for me, minus 5 plus 1. And here's where I messed up. I messed up because I counted this as one of my potential critical points. But I can't count that because they said stay 0 to 6. If you counted that, you got D. This is what I got. And you messed up. But -1 is not. Don't count -1. You see what I'm saying? I counted -1. So I had some kind of stupid number line that did this. And then I just threw -1 right there like a big dummy. I don't know what I was doing. Okay, but anyway, here's 5. So I put -1 after 0. Well, I got really mad because in bold pencil I put not in your interval on beside -1. But anyway, whenever you calculate this, you get a negative, you get a positive, you get a negative, you get a positive. It asks for a maximum value. This is coming in at a minimum, so this is one where you had to check your endpoint, see which one gives you the higher value. It actually, so I said f of 0 is 0, f of 6, if you plug that in, 125 minus 150 minus 75 gives you negative 100. So where's your maximum occurring? Here's your maximum. Maximum value is 0, but it also occurs. Chugging right along. Did you know? Okay, so I knew I was into something with 17 whenever I saw the arctans. 9 times out of 10, if you see that, that's probably what they're doing. So my first thought whenever I started this was, oh my gosh, what am I going to do? How am I going to get? I knew it wasn't log. I eliminated that right off the bat, and I eliminated D because those just. Well, because if I went back and did the derivative of that, if you can't figure out how to do the integral, look at the answers and take the derivative of them. You take the derivative of the log of all of that, well, then you'd have 1 over all of that, then you'd have to chain it, right? Okay, so right off the bat, I eliminated C. I also eliminated D because same thing. There's no chain showing up there, so I knew that those two were wrong. So I knew I was looking at an inverse trig type situation, and I know that those look like, and even if you didn't have time to get into it and you couldn't remember, you've eliminated a 50-50 shot, right? It's usually going to be inverse tan. That's what I usually, that would be what I go with every time. That's what this one came out to be. But just to show you how it works. So for this one, you have to complete the square. The pre-cal way, not the algebra 2 way. We're doing it, so in other words, 1 over, and I know to do this because I know it's something squared plus something squared. I know that that's in the bottom of every one of those, whether it's in a square root or it's plus or it's minus or whatever it is. I know it's something squared and something else squared. So I did x plus 4x. To complete the square, I'd need a 4, right? And then I've got this 5 over here, and I have to counter that with a minus 5. Y'all remember doing this? So if you complete the square, normally you're completing the square to solve, but then whenever we got a pre-cal, we completed the square to change the form into vertex form. Okay, so I've got x squared plus 4x. I need a good C to go right here, and I've got the plus 5. But when I add the good C, because I'm on the same side of the equation, I also have to subtract it from the same side. Whereas before in algebra 2, we added it to both sides to keep our equation equal. Now we're going to add and subtract at the same time to keep it balanced, right? If I give you 5 and then I take 5 away over here, then I've not done anything other than right? So this becomes x plus 2 squared plus 1. You could work backwards on this one. If you know the derivative of arctan and arcsine. Yeah. So either way would be okay, but this comes out to be 1 over x plus 2 squared plus 1. I did a little u sub, and I let u be x plus 2, which means du is yes. So I end up with 1 over u squared plus 1, which or 1 plus u squared, same thing. Inverse tan. When I got to that point, I didn't do anything else with it once I could see that it was something squared plus 1. $18. Yes, no, maybe so. Need it? If it ever asks you for an approximation using a line, we're just writing the tan line here at that particular point. So remember, tan line, I need a point and a slope. I have a point, and then it may have confused you with this f of 10, but that's what they're asking me to find. They're asking me to use my tan line to approximate this. So let's write the tan line first. Derivative here, 1/3 x to the negative 2/3. I need to find that at 8 because they gave me this point 8(2). Nicely enough, they gave me, I didn't have to solve it for y, they gave it to me, but I do have to find the derivative so I can have my slope. 2 to the 8 is 2, 2 to the negative 2 is 1/4, right? Are y'all following me? So my equation for my tan line is y minus 2 equals slope x minus 8. And all I have to do at this point is put a 10 in. Y minus 2 equals a 12 times, that would be a 6 plus 2, 13 over 6, which is 19. Did y'all love to call it play? If you did, you got the right answer, which is 3. Anybody need it? Yeah, kind of. Because if you plug in this as it sits, you end up with 0 over 0. And it may not look like that at first because you've got this but e to the 0 is 1. 1 minus 1 would give you the 0. So L'Hopital, the first time I get 8x over e to the 4x, but chain it with a 4. And if I L'Hopital, if I plug it in now, I still get 0 over 0, so I L'Hopital it one more time. 8 over 4e to the 4x. So 8 over 16e to the 4x, and now I can plug that 0 in. That just gives me 1 here, 8 over 16 half. So this is the point where I plug 0. So I L'Hopital it twice, right? Derivative top, bottom. And then if I plug in 0 here, e to the 0 is 1. That goes away, so 8 over 16. So L'Hopital at once is going up a 0 over 0. How about 20? First thing I did on 20 was I did AROC because I noticed they were talking about the first derivative there. And when it's one of these, it's one of those that there's only one answer, so you pick the best answer that you can find. So between 0 and 10, I found AROC, and I found AROC to be 20, and because of that MVT, that mean value theorem, and that's all they were testing me there. That means that that AROC has to equal IROC somewhere. And since that was choice B, that was definitely the best one. 21 wasn't as hard as what you think it is. Derivative of E. What happens here? They cancel, right? This is one of those where they cancel, and as long as it doesn't matter what number is here, as long as this is just X, I replace the T with X and I'm done. But if it's got more than one part, y'all remember when we did this? If it's got more than one part, I replace the T with whatever that variable is, that is the square, and then I have to change. We did a few like this. We didn't spend a long time on them because they were so easy, but you do have to be able to recognize them. That's the key there. But you're looking at that bound. That bound can be a variable, but you do have to chain it. You plug that variable in and you do it. At least I can talk this week. Yeah, because it's a constant. It's a value. If it's any number, it doesn't matter. How about slope field on 22? Did y'all get that one? As I looked at a slope field, the very first thing I always look at are zero slopes. And so I noticed on the x-axis they were all zero. So when y is zero, the slope is zero. So that automatically eliminated A and B for me to start with. And then I was just down to between positive and negative. So I picked a point. I picked the point 1, 1. At the point 1, 1 on my graph, that slope is negative, which means it couldn't be C. It had to be D. So if you wanted to pick other random points and keep going through, you're welcome to. Because at 1, 1, A would have worked also, but of course that 0 is where it flew. Does that make sense? A would work at the point 1, 1. No, it wouldn't. My bad. You're right. 23 was the hard one. 23 was the one that I will argue that you do not have the tools because we do not do integration by parts in here. And I think that you need integration by parts to do this one. So I would say for this, did you do it? Okay, tell me what you did. Okay, so if you did U sub with X plus 1, I'm just interested to hear this one because this is the one that I looked up and I couldn't figure it out without doing by parts. And then my brain. All right, so if you do U sub, then you have X over, yes? But you didn't actually work it from there. Okay. Yeah. Well, that's what I did on these. I took A, B, C, D, and I started working backwards and finding the derivative of each one until I got back. I did, okay. I was going to say that. When you have two functions in there and you can't get them with a 1U, then it's an integration by part. So that one was C, but again, you had to work backwards to find that. How about 24? Answer's A. Okay. First of all, while I write this, tell me what is a removable discontinuity? It's what? close. It's a whole. It's a whole. A removable discontinuity is a whole. A non-removable is an asymptote. And we say it's removable because we take just that one point out and we can plug it with something else. Right? So x squared plus 7x minus 8. This bottom will factor x minus 8, x minus 1. So the top is 2x plus 8. I'm running through this fast. I'm assuming you all can factor, especially when that leading coefficient is 1. And so removable holes. How many holes do I have? Just one. 8 is an asymptote. Because it almost cancels, but it doesn't quite. So 1 only. Little pre-cal question thrown in there. 25 was one that I also worked backwards on. I have this one starred. You did this one? You did? What'd you do? Oh, you're saying, but you used the answer choices and worked backwards still. You didn't find, yeah. So I worked backwards on this one also. I went through the answer. Luckily, A was the answer. I started working it out, and then I've got all this scribble and said just plug in the note to tell y'all. You couldn't because for this one, since it's second derivative minus 4y equals 0, if I try to integrate here, I can't get that constant of integration, right? I'll end up with that plus c with no way to find it. So what I did instead, start back at y equals e to the 2x and work your way backwards. So first derivative is e to the 2x, and then you chain it. Second derivative, and they were such easy functions to take derivatives of that I think that was the times 2 again. So I get 4e to the 2x. And so if I plug that in, yeah. So if I did second derivative minus 4 times y, would that equal 0? Say yes to the derivative. So this is now e to the 2x. You didn't get what? From this point on non-calculating. Okay, now I will say, remember that as you go through these, I do cut this time a little bit shorter than what you'll actually get. So it's the only way to work it, but it's only about like 5 minutes. But if time is an issue, it might be something for you to circle one, go on and work through the ones you can, so you at least get all the points that you can. I struggle with time a lot of times too. All right. They don't expect you to know every single one. That's the point. It's supposed to push you. Yeah. Well, it's hard. It's hard for me to know how to do a problem, know that it's going to take me a long time to do it, and intentionally skip it to go to another one when I know that I know how to do it. But sometimes you have to do that. Go, but this one's going to take me a really long time. I'll come back and do it. Let me at least answer the ones that I'm for sure. All right. How about 26? Continuous function. 2 critical points in the open interval. Which of the following must be true? I chose D because, and I literally did this on my table, from 10 to 11, let me just write them all, from 13, 6, and 14, 5. This is f of x. And so here, I'm going down, I'm going up, I'm going up, and I'm going down, right? So decreasing, increasing, increasing, decreasing, and it says which of the following must be true. Well, if you look, the derivative at 12 right here, if I'm going from up to up, the derivative can't be 0. Now it's going to be 0 somewhere in between where I'm switching from up to down or down to up, but it can't be 0 there because I'm steady going from up to up. Does that make sense? I can't change signs. Okay, what's A say? F of x is bigger than 0 in the open interval from 10 to 14. Right. What if at 10.5 it jumps down to -1, and then at 10.75 it jumps back up to? If you don't know what's happening, because it's continuous, it could be doing all this in between and then jumping back to there. Woo! That was a doozy one. That was one that I probably should have skipped and come back. Let's see. I've got this equation. I didn't even ask y'all about this. I assume you do. Well, it's a differential equation, and it's a pretty nasty. Find the value of dc dt. So I know that I'm going to do some implicit differentiation here. I'm just going to go ahead and find the derivative. Everything I'm doing is with respect to t. So every time I take a derivative of a variable, I'm following it with d whatever d. So I got 2p equals. Chain will get you here, so be careful. 3 times 20 minus c squared. Now chain it times -1c dc dt. Oh, just one. All right, so I've got 2p, and I'm just going to clean it up just a tad before I start plugging in. You don't have to remember. There's no amount of work you have to show. This is multiple choice. Now I'm going to plug in what I know. dp 41 c 5. Did I copy it wrong? And then why did I draw a line to c there? Do I have to? What'd you say? I solved it, so I found c. I'm sorry, I found p. If p squared is 20 minus c squared and c is 15, or cubed, not squared, then p squared is 5 cubed, right? 125. So p is the square root of 125. And judging by how the answers are written, I went ahead and did this for my p. I wrote this in twice. All right, and that one goes in also for p. So I have 2 times 5 root 5 times 41. 20 minus 15 squared. This was tough to not have a calculator for, I thought. I have little long multiplications off to the side and all. Let's see, I got 410 root 5 here. 10, 410 equals -3 times 25, which was 410 root 5 over -75. And then I just had to clean it up again. Divide both of them by 5, which would be, ooh, that one was nasty. Robert, I bet you got 28. That's a Robert problem. Well, not well, but they're really, if you think about it. I just plugged in infinity, not even caring which one was on top and which one was on bottom, because essentially I just canceled them out. Because let's see, it's pretty simple. Yeah. I just knew you were gonna get, because that's the one that you understood. I know. Well, because if you have 2 raised to the infinity or 5 raised to the infinity, regardless or not, they're both kind of it's infinity, right? Well, but even if you flipped them, then that would put that one up here and this one down here. You're still kind of infinity over infinity. It's like 1 over 1. So I just kind of went away with those and put the. Yes. I thought 29 was kind of good. Let's see. Intersected the point 0, 0, 1, 1, and 2, 2. I hate the ones that are the 1 and 2 only, 1 and 3 only. 2, I hate those because I always feel like I mess up. What did I do here? Which of the following expressions gives the area enclosed by the graph? I did label my graph x and g of x as which one was which. I did some shading and did them in different directions so I could see what happened whenever I subtracted them. If you do, for the first one, if you do x minus g of x over that entire interval, x minus g of x, what happens is, all right, I've got this x. I knew it was 3. I got 3, no problem. I'm trying to think of why I chose 2. It is, it is. So that absolute value is still going to give you. Yeah, it's going to give you that area under, even if you reverse them there. It's going to take that, because you're doing the absolute value inside the integral, it's going to take into account that you're not necessarily doing top minus bottom, you're doing bottom minus top at one point, but it's okay because you're doing absolute value in there. So that's why that was wrong. So be D, 2 and 3. Those are so. All right, and then the last one, which is 30. We're never going to get through all the rest of the calculator. Next time I'm starting on calculator. We never get through the calculator part. It was step 2, and I hope you just went through and started doing the antiderivative there, and you saw you can't do the antiderivative of 1 over y cubed is not log y cubed. You have no chain there or anything. You don't take anything into account. The antiderivative of 1 over y to the third would be, you say, well, that's y to the negative 3, so it would be negative 1/4 y to the negative 4 instead of, I did that wrong. But you're not going to do. Log is whenever it's just 1 power, so if it's 1 over y, that would be natural log. Or 1 over y plus 2, that you could do natural log of y. So that would be. All right, so that was multiple choice of calculator. Now let's look at non-calculator. I'm sorry, I know this is boring. The ones just to get bogged down on. Yeah. All right, 76. Everybody good or you need it? Speaking of purple HP, the graph of the derivative. I did a little sign analysis for this one. The derivative, which is the graph, tells me what the graph is doing because it wants to know when is f increasing. So I want the zeros of the derivative, which happens to be what I've been given. So I got -3, -1, and 2. And it goes negative, positive, positive. So where am I increasing? I'm always increasing. Yeah. Am I wrong on here? Did you bubble MB? I marked it wrong anyway? Did everybody else get it marked right or wrong for me? Wonder if you're 77. Let's see. What'd you get for 77? C? Oh. Is your number right if you can't how many you missed? It is right. How about 77? Everybody good? You got a rate of a rate there. That's what you're looking at because they gave you a rate to start with, and then you take the derivative to get rate of rate. Still don't need a calculator. 78. Particle moves on. I'm assuming you'll need 78. No? This. Velocity is 4 over t cubed plus 1. The position of the particle is x equals 1 when t equals 2. So x of 2 is 1. So I'm doing an antiderivative here. So 4 over t cubed plus 1. But I need to do it as from 2 to 4 plus 1 dt. I had to do this as a fundamental theorem one again. So x of 4 minus x of 2 would give me this. I did this on my calculator and got 0.35257 to 4, and then x of 2 is 1. Sometimes I forget that I've got a calculator, and that will really help me on a lot of these problems. 79, the graph of the function f is shown above of the following intervals, which is f continuous but not differentiable. So if it's continuous but not differentiable, I'm looking for corners and cusps and vertical tangents. And I think you can see that that happens right about 2.5. Looks like there's a non-differentiable point. So somewhere between 2 and 3, it's continuous but not differentiable, so that is C. 80, the first derivative of the function is given by blah, on which of the following intervals is the graph of f concave up. And so what I did was I graphed this equation, f prime of x equals x squared plus 1. And so you put this in your calculator and you literally look at it. And I have a note here to make sure I told you right before y'all get confused. Look at the slopes of this one, because the slope of the first derivative gives you the sine of the second derivative. And the second derivative is giving you the concavity, right? So I'm looking for where the slopes are positive, and it's the slope of the derivative. So where is the derivative increasing? Yeah, which is A. That one you're going for maxes and mins, if you like to think about it like that. That's again, that's connecting those graphs. 81, yay or nay? Don't do it. That was straight on your calculator. That was just the integral from 0 to 3 of r of t. You put r of t in y1, you get 5.40. 82. 82 was your definition of IVT. IVT, to use intermediate value theorem, it has to be continuous. Let's see. 83, acceleration. It's wanting to know when the particle's velocity is decreasing most rapidly. So I'm looking for the biggest negative slope of velocity there. Or the easier way to look at that is the lowest value of acceleration. When acceleration hits a minimum, that's when the slope of the velocity hits a minimum. And so if you graph it and look, you found that the minimum occurred at 1.420, which was B. 84 average value, that's a 1 over B minus A. 1 over, y'all did not do as well with the calculator as you did the non. You thought what? Let's see. Oh, well, it says the average value is 3, so I did this. I just set it equal. What's the area of the region enclosed by? Oh, I did. Oh, I just did this and I said 1/2. I multiplied both sides by 2. It's 6. So this has to be 6. But if you just did a square, that's fine too. So y'all didn't even use the first part of the information that they gave you. That's fine. If you work, that's fine. 85, the function f is continuous and increasing when x is bigger than -1. Table above gives the values, the following which is the best approximation for the limit as x approaches, e raised to the -2. So I said, it looks like between, when I approach 0 on x, it looks like f of x is approaching 0. Do you agree with that? So all I did was I took that equation, e to the -2 f of x, and I put a 0 right here. And e to the 0 is 1, which is c. Gross on 86. 86 is an isosceles triangle. Again, this was calculated. You got to remember to let the calculator work for you. I put the first equation in y1, the second equation in y2, and then I just set up my little volume. Actually, I wrote the area first. The area, because it's an isosceles triangle, so it's 1/2 base 1 half. Yes. The area, again, remember you're on your calculator, but this you probably plugged in wrong if you missed this one. This is the area of the triangle itself, because the legs are the same, it's isosceles. To find the leg, I had to do top minus bottom, right? And it's squared because both legs are the same. So 1/2 base times height, but base and height are the same, so I squared it. So to find the volume, all I did was integrate from 0 to 2, all of that. And that I did on my calculator. And I got a 1.77. No, because pi is only used if it's 1 if it's a circle, or 2 if it's revolving. When it starts revolving, you end up in a circle. About 87. 87 was pretty straightforward. It was just pulling those apart. 3 times 5 and then -7. Yeah, you need it, or yeah, y'all are good. Good. 88. Ooh, 88 was a good one. Twice differentiable function. I had to draw a little picture here. It told me it was concave down. And so here's concave down. This is my curve. Then it told me a secant line goes through it. So here's S of x. And then it talked about a tangent line at this point. So this is tangent. And so if this is at 4, right, it's asking me to approximate which one's bigger and which one's smaller. It took me a little bit to wrap my brain around this one because I had to think, okay, this is 4, right? So 4.2 goes to the right just a little bit. So if I'm here as compared to here as compared to here, well, the tangent line is the highest, right? Because it's overestimating if it's concave down like that. So that's the biggest value. My smallest value is coming on my secant line, and then the actual value is happening right in between. So they're kind of going down, and then I just picked the one that looked, which was C. They were the other way around, but it was C. Right? The number of insects, and I've got this population equation here. P of T. Y'all need this one? No? Yeah. It gives me an initial, which is 40. And then it just asks these questions. I went through, I did integrate here and found that P of 10 was 2840. The derivative was 360. I found all of these whenever I worked through because it's only asking me about time 10. And I found that 1, 2, and 3 were all true. Yeah, you just had to go through and find those derivatives. Yay, the last one! And I know I went really fast. I'm really sorry. Selected values of the increasing function h and its derivative are shown. This is one of those inverses where you have to flip over to find it, so it's 1/5. You go to where h is 7 and you flip over 1/5. Yes.